What do you think data center operators, whether it's AI data center factories or HPC or traditional colocation data centers or mining owners, what do you think that they most misunderstand about how the utility companies and the grid operators actually see them?
I think the first misconception that's starting to change is that the assumption that the power is there is that assumption is false now.
That somebody else will figure it out.
Yeah, the power is not there. And then starting to understand, I mean, we've been working on this for years with our partners. We've built an ecosystem of different technology partners. The other assumption is that data center load is not flexible, and that's coming out of our traditional data center customers who are really real estate investment trusts, and they pass the energy costs through, and the energy's always been there for them. What we're starting to see is in this new type of data center, the AI factory, because loads can be geographically shifted in and out of different constrained grid regions, and we can actually flex everything from the storage to the cooling to the compute itself without pausing the work, without harming the SLA and the quality of service. We can actually bring that flexibility now. So the assumption that the power is there is false, and the assumption that the compute itself can't be flexed is also false now if we're talking about large AI inference clusters, anywhere from a 10 megawatt cluster to a gigawatt. So there's a new this new data center type, the AI factory. It's possible for this type of large load to not be a burden on the grid, but to be an asset for the grid by having all of these flexibility levers that I've been mentioning going in to the interconnection agreement. So that gives you your best shot of having that power there when you go in ready to work with the grid.
It's really fascinating too, as you're explaining flexibility, because that's only something that landed on my radar screen maybe 6 months or a year ago. But the idea of flexibility on the infrastructure, on the IT infrastructure side, as opposed to the facilities infrastructure side, has been around for, I guess, a good 15, 20 years at this point. When I think of flexibility, I think of elasticity, like Amazon Web Services, dating back to the late 2000s, early 2010s. So everyone's very, very comfortable with that idea on the compute, on the technology side. On the energy side, I imagine takes a lot more education.
So many things it's just a brand new world with the AI factory design and the way that those power profiles move. They're incredibly spiky. Talking to these engineers at all of these conferences that I go to the past 2 years, you might see a spike of a large cluster, let's say a 10 megawatt inference load, 100% power suddenly spiking up from 30%, finishing the workload, going back down. These are massive swings utility is not really able to deal with. So what we're seeing for the first time is because there's so much capital also being thrown at AI factory development, we're seeing battery storage, which is the number one thing that we really need right now to kind of trim those peaks and those peak hours. Battery storage is being used for two reasons on the operator side: to surround, create a digital moat around the very expensive AI compute that's just been unboxed and racked up, right? Protect the power quality coming in, but also to help tame those huge transient swings. And then thirdly, the battery storage gives you a flexibility lever, again, to speed you through interconnection. But yeah, all the way to the rack. I mean, there's flexibility measures all the way to the rack. But that's another new thing that we've been seeing, is storage getting adopted very quickly, which is what we love to see.
ESS or BESS, I hear a lot about the energy storage systems.
Yeah, and we're partnered with several large data center infrastructure providers, and they're confirming that also there's a real appetite for BESS for energy storage right now.